Okay, so now that we practiced that first one, I'm going to have you practice this one, just so that we're all on the same page. Let's establish the currents here. Let's say that the current in this first section is coming around like this, and we'll call that I1. We'll say that the current coming around in this section is I3, and the combination of those two, I1 plus I3 equals I2. Let's also go ahead and establish the loop directions. So let's establish the loop on the left going around this way and the loop on the right going around this way. So yeah, go ahead and pause the clip and make your three equations for the three unknowns. And let's do that first before you start doing any of the algebra. Let's see if you can get the equations right, and then we'll go from there. So go ahead and pause the clip and see if you can get the three equations for the three unknowns, and then we'll go from there. All right, so I1 plus I3 equals I2, so that's Kirchhoff's current law. On the left-hand side here, we should get positive 5 plus positive 10 plus negative 4I1. Over here, we should get positive 5 plus negative 4I3 plus positive 5 plus negative 4I3. And so those are our three equations. So yeah, at this point, I want you to go ahead and see if you can figure out the current in all three using these equations, and we'll go from there. So go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. Okay, so the current in here, 3.75 amps. Over here, we've got 1.25 amps, and then we bring those together and we get 5 amps. And because all the signs work out, we know that the directions that we chose do work. All right, so let's say in this one we have 6 volts, 6 ohms, 2 ohms, 9 ohms. On this one, I'm going to have you create your own currents and create your own loops and see if you can work it all the way through. And you know, I'm going to have maybe different setup than you, which is fine. Let's see if you can do this on your own, and then you can use mine to confirm. And then if you want to, even, you know, after you solve yours and you see that mine is different, you can, you know, click back and fix your mistakes there and see if you can check it again and see if you can get it. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. All right, so I chose current here, and then current 3 going like this, and so I chose for I1 and I2 to combine together to make I3. So I1 plus I2 would be I3 there. I chose my loops to go around like this, and so this loop would have negative 2I2 plus 12 volts, and then plus negative 9I3. The bottom one, positive 6 plus negative 6I1 plus negative 12, because my loop is coming around like this, but I'm going for the positive terminal, the negative terminal, plus 2I2. Okay, so place I1 plus I2 in for I3, and I can distribute there. And then I can get it to where I've got I2s and I1s are left. I can isolate for I1, place this into here, and factor the negative 6 in, and I'll end up getting positive 1.5 amps. So I know my I2 is okay. So whatever you said for that middle one, it should be going to the left at 1.5 amps. Now, if you set it up to where you said, oh, I think it's going to the right, that would have been fine. You should have still gotten 1.5. It just would have said negative 1.5. For the I1, I got negative 0.5 amps. So what that means is the current is actually going around like this, because I got a negative. And so I just got the direction wrong. So the current's going around like this. And then over here, 1 amp, so that is true. So the current is actually going this way at 1 amp. It's just the only one that I got backwards is really I2 is going the other way. So let's go back to one like that. Let's say we have our 6 volt sources. We have 3 voltage sources in this one, and we have a 4, 8, and 2 ohm resistor. And I'm going to let you choose on this one the direction that you want for the currents, and choose your loop directions with the, your loops, and determine the currents with 3 equations, 3 unknowns. So go ahead and pause the clip and work this one all the way through, and let's see if you get it. And then if not, you can go back and try to fix your mistakes and see my method as I did that. So go ahead and pause the clip, and when you're ready to check, you can give it a try. All right. So I chose for the bottom loop I1 to come around like this, I2 in the middle like this, and I3 like this, and therefore I1, which is coming in, I2, which is coming in, is going to form I3. So that's going to be one of the equations. Our top loop, I went ahead and chose to go around like this, and so we have negative 4I2 plus positive 6 plus positive 6 plus negative 2I3. The bottom loop, negative 8I1 plus positive 6 plus negative 6, because our loop is coming around like this, but we're going from a positive terminal to negative terminal, plus positive 4I2, because we're saying my current is going to the left, but my loop is going around to the right. And we've got our junction there, I1 plus I2 is I3. So these are our 3 equations. I'm going to isolate my variables. I'm going to solve for I3 and place this in for I3, factor that in. And so now that's good. I've got I1s and I2s, which I have with my final equation. I can simplify there and place this into here. And I get 0.857 amps. So the bottom one should be going in this direction and is 0.857 amps. Place this into here, I get 1.71 amps for I2. So here is I2, which is going this direction, and that works out. The signs work out, so it is 1.71 amps going that way. And then finally, I3 is 2.57 amps, and it is going in this direction. So we've got that in there.